I started to get involved in pharmacology because towards the end of the course I was doing in chemistry at Oxford, I couldn't really get excited. I couldn't see a purpose to what I was learning. I could appreciate the slick new synthesis of this or that or the other. I could see that chemical sleight of hand was really fun, but I didn't see what was at the end of it. And in that last year, you are allowed to take a special subject, and there was a special subject in chemical pharmacology, which I knew something about because one of my predecessors at Corpus, and as it happened in the Department of Pharmacology, was a chemist and who had done this course, and so I knew a little bit about it, and it was a bit different from the biochemistry special subject which most of the other chemists took. So I thought, well, let's have a go of this, and I did, and it was interesting to me because I could see that this was chemistry which was pointing at improving drugs, that you could design or try to at least design drugs to carry out specific pharmacological actions because you had a natural compound, like, for instance, like atropine. So how can we get something which does the same job as atropine, but you make it in a test tube rather than growing it in a plant? That was really the basis of what, as far as I thought. So that's what I did. And I enjoyed it, the course. And rather importantly, it was one of the, I think, 2 examinations I had ever enjoyed doing. I really enjoyed 3 hours writing about it. I used to hate exams, but that's wonderful. So I had a great time. And as a result of that, I did my part 2 in the pharmacology department with H.R. Ing, who was the resident chemist in the pharmacology department in Oxford, and he had, been involved with the whole idea of structure-activity relationships from a very early time, in 1930s, something like that. He started doing it. So that was, I did my part 2, and then I did my I did a DPhil in the same department, doing chemistry, trying to make simple analogues of digitoxin, digitalis. The great, the same idea that you've got something which is essentially a herbal remedy. You have to grow foxglove plants and extract it, and then they have to standardize it. Quite a lot of fuss. And if you could make a chemical which you could purify, produce, and have the same effect, there was an end to what you were doing. And that was really how I got started. And I sort of never went back to chemistry. But it's always been good for me, I think, because it gives me certainly in those days, it gave me an almost molecular view of pharmacology, because most of the pharmacologists at those times, that was say very early 60s, were medically qualified or physiologists who knew a lot about physiology, but they found it very difficult to grasp what's known as the mole concept. The fact that grams of something doesn't necessarily tell you the whole story. You want to know how many moles there are, because that's the real way of finding out potencies.